nanohub.org.
Online simulation and more for nanotechnology.
Thank you all for joining us today for a guided tour of interactive Jupyter Notebooks powered by nanohub. This workshop is presented by Daniel Mejia, who will discuss the Jupyter Notebook tool on nanohub, highlight some of the features present on these notebooks, explain some key concepts, and demonstrate some showcases. Daniel Mejia received his bachelor degree on systems and computer engineering from the Universidad de los Andes at Bogota, Colombia in 2002, and his master's degree on engineering from the same university in 2004. He began his doctoral studies in 2004 in the fields of virtual reality, human-machine interaction, and graphical programming. He received his PhD in electrical and computer engineering at Purdue in 2018, with his main research focused on visual analytics. He also worked as a lecturer at the Universidad de los Andes from 2004 to 2009. He has been instrumental in the development of Nemo 5 and nanohub.
So thank you, Erin, for the introduction. My name is Daniel Mejia, and welcome all of you today for this guided tour of interactive Jupyter Notebooks powered by nanohub. I'm going to be jumping between the slides and the Jupyter tool on nanohub, showing some of those examples. And all these examples are going to be public on a nanohub tool, so you can go and browse through all those examples that I'm going to show. So my agenda for today is first just give you a broad introduction about Jupyter, what Jupyter is, and what concepts like IPython and kernels means. And then I'm going to jump to the tool to show some of the new features that we have in Jupyter on nanohub, internally called Jupyter Plus, but it's a collection of extensions that we install on nanohub that will help you when you are developing tools or notebooks on nanohub. Then I will switch to some of the examples in how to work with atoms and molecules, how to visualize molecules, atoms, and different packages that we have installed. Then I will highlight some of the kernels that we have, in particular the Matlab kernels that we have installed, and how to just dump information from Python and load those onto Matlab and start working on that process. I will highlight some data analysis packages that we have, like pandas and some of the results database that we have from nanohub, and some visualization of data. And at the end, I'm going to show some packages for do GUI development. So we have ipywidgets and additional library that will allow you to create interactive notebooks or applications, interactive application based on Jupyter. So I will start with Jupyter. So Jupyter started in 2001 approximately, but it was not called Jupyter, it was called IPython. It was created by Fernando Perez, Berkeley University. The main idea of what his point of view was is when we had Python before, it's just like any other language or programming language. You set the inputs, you have a script, you run the inputs to the script and go to the outputs. But when we are doing research, it's not that kind of way, because we know what we are starting with at one point, but we don't know when we are going to end. So probably you have been familiar with this kind of cartoons that in science or when you are doing a PhD, you have to basically, you don't know where you are going, and at the end you are going to achieve something that probably was not your main scientific goal, but is a real nice support or improvement to what the state of the art at that point. So IPython started as a terminal thing. So basically you can just run this IPython. That is a screenshot of the IPython version of Jupyter, call it that way. The idea is you on console, you can just type those arguments and you have like a workspace. At that time, we only have like Matlab or Mathematica to do that kind of thing. So IPython was a really nice feature to improve how Python was used at that time. IPython evolved, and at some point in 2014, it became Jupyter as we know it right now. And particularly Jupyter was called because it didn't want to be focused on Python, it was to be focused on different languages. And if you know, the name of Jupyter came from the three main languages used at that time for scripting. That it was Julia, Python, and R. That is where the Jupyter name came from. We have multiple kernels that are supported through Jupyter. There is a link on GitHub when you can use. If you are interested to install a specific kernel for a specific language, you can download it and install it in your local instance of Jupyter. The kernels, there are some more popular than others. Of course, the most popular is the Python kernel, the one that we use most of the time. But there are other popular kernels. The main problem with those kernels is there are some programming languages that need to be compiled, so particularly the Java or the C++ languages that need to be compiled to get a binary to just run your code. That doesn't work well with the Jupyter concept. So on nanohub, we installed the most useful or the most used kernels. And the ones that we have installed on nanohub is the Python kernel with different modification for specific packages. So if a library requires a specific cluster of packages, we install a kernel for that particular library. We have the Matlab kernel installed, and in the older version of Jupyter, you can get access to the R kernel and the Octave kernel if you want to use them. The most common or the most useful or the most used one is the ipy kernel or the IPython kernel. Is mostly because all the libraries in the Python ecosystem. So in the R kernel, you can find interesting statistical libraries to use. But in the R, you can use like the pandas for the statistical problems, but you can use ipy for scientific problems and visualization with Matplotlib. So we have a lot of libraries that can be integrated, and that is the power of ipy kernel and what we have on nanohub for all those kernels. So today I'm going to highlight the Jupyter 7 instance that we have on nanohub. So Erin just published the link to the tool. So if you haven't clicked there, there is the link there in the slides as well. And all the examples that I'm going to show, I'm going to highlight, are going to be in this Jupyter Guide 7 tool that is available. I'm going to update the tool with the last version of the examples that I'm going to show. So you can go and browse and explore and play with those examples later after the tutorial. In tools, when you are running Jupyter 7, you have access to your main home directory. So all the data is going to be modified, is going to be preserved after you close your session. But if you are running the Jupyter Guide 7, you can create notebooks, you can modify the notebooks, but when you close or you finish your session, all that information is going to be lost. So be careful that if you want to keep your data, you need to be running Jupyter 7 to save your notebooks on your home directory. If you are not logged into nanohub and you log for the first time to nanohub, this is what you are going to see. There are some slides that I didn't show at the beginning, but mainly what you can do is in all tools, you can say, show me all the Jupyter. It will show all the instances that we have of Jupyter. So the last one is 2021. That is the package, the main content installation that we installed in 2021. And we have Jupyter Live using the same environment. But there are other versions that use all the Python versions, and particularly if you want to run old codes like Padre, Nemo, or those old codes that are installed, or particularly for Rapture tools, you can use one of the old notebooks or the old notebook versions. So when you run notebook, you will go directly to something like this. You will get to all your files. You can, if it's the first time, you will only see the data. That is basically where all the results and the information for your sessions have been stored. But one of the main issues or the main features that we have now is you have a filter, so you can just filter for a specific folder and a specific notebook that you have. We didn't have before. If you need to file for specific upper or lowercase, you can enable that. So I'm going to go to the guide. That is the examples that I'm going to show. And the Jupyter guide is going to start with this notebook. So it's just a description of where the package installed on that Jupyter instance, documentation about Python, documentation about Jupyter, interesting notebooks that's run by the community. Particularly from NanoHub, you can get the user's manual, that is how all the interface of Jupyter works. Some examples, that is what I'm going to be focused on today. And if you want links to how to learn Python and how to publish notebooks as tools when you have an interesting notebook that you want to share with the community. So I'm going to start with this tutorial that is just a blank notebook, just to highlight some of the main things that we have now on NanoHub. The first thing that I want to show is, if you are not familiar with Jupyter and Jupyter Notebooks, we have different type of cells that you can run on a notebook. So the first thing is code, that is the default one. So you can define, in this case, Python code. So I can say my variable is equal to, and then it run and just assign that value to that variable. But you can also have documentation and use the markdown version of that. So then you can add some comments or just improve your notebook. One of the main things that we included with this version of Jupyter is now you have a preview of the markdown code that you are doing. So if I say, for example, tutorial, you are seeing what your final version of that markdown code is going to be. So next I can use, this is going to be my first part of the tutorial, and then I'm going to say this is going to be playing with libraries. To execute the code, I can go to say run or do shift return or control return, and then it's going to execute it, and you will see this as your documentation. So the first thing that I want to say is I'm going to play with a library that is now installed on NanoHub. So for this, what I'm going to say is I can install libraries on NanoHub in my local repository or in my local folder using pip. So I can say install this library called art. So it's just a funny library just to render text in a funny way. So that is going to install that library on my desktop, right? So now you can see it's installed on .locallib. That is my local version and my user Delphi. It says that maybe you need to restore the kernel, but since it's the first time that I'm importing, I can say import art, and the library, is going to be loaded in my workspace. But one of the things is, if I want to run it again, I want to say, for example, rerun all my notebook, restart or run all. So it's going to run all the steps that are in my notebook. But it's going to try to reinstall the library again. And probably that is not something that we want to do. So one feature that we have now is you can block the cells. You say, I'm going to freeze this cell. So it means I cannot modify it. If I try to execute it, it's not going to be executed. And if I say run it again completely, that cell is going to be ignored because it's now locked, right? So I say run it again, so I can import it multiple times, but this one is locked as the first time that's run before, right? And now I want to play with that, so I say art.tprint. I will say, let's write the nanohub text, nanohub, and just see what happens. And it prints nanohub in a funny font, right? I can say, well, now I say font equal to random, and now it's printing in random font. So every time that I print it, is going to get with a different artistic font. And if I run it again, run all, again, those two cells are going to be executed. This one is just freeze. It's going to be kept as it runs at that point. So that is an interesting feature that we want, but there is another possibility. So now I'm going to create a markdown here, and I'm going to say here, I'm going to say some part, part of my tutorial. I want to say this is going to be adding numbers, right? So I created this additional point, and I want to create two variables, a equal to 5 and b equal to 2, yeah, two random variables. So if I run them, well, they were assigned, but assume that those were constants in my code or in my notebook. I don't want somebody to go and modify this value over here. And what I can do is I want those cells to be executed, but I don't want to be able to modify the content of that cell. So that is what we can add this lock. So then if I want to execute it, that is going to be executed, but if I want to destroy the code, it's going to be locked. So this is another feature that we have. So you can lock and free cells. Yeah, if I want to modify, I can unlock the cell, and now I can just mess with that cell again. But there are interesting features that we can introduce for notebooks. So let me just keep it that way. I'm going to add more variable like c equal to a plus b. Right, I have a variable. So I assign A, I assign B, and I assign C. I don't remember what the value of C is. So one way to do it on a notebook is just print C, right? But let's say it's a complex workflow or a complex notebook that we don't know what are the values. We can go and inspect what are the values on my system. So I can go to this click variable inspector, this button, and it is going to see those are the values that we have in our workspace or the kernel enabled at that point, and I can see that C is an integer that is a value of 7. So if I randomly say, well, what happens if I say D is equal to C plus 10? So now I have a new variable with the value 17. So I can close this again, or if I want, I can start moving, minimizing. Yeah. So it's another cool tool to help you. What is the install? What is the state of your notebook at a specific point in time? I'm going to create a function. So let's say I'm going to create now a function that is called function A, right? It's going to get two parameters, parameter A, parameter B, that are going to be numbers. Right, so I'm at a comment that this is my function, right? I'm going to do a conditional. I say if my value of PA is negative, I'm going to assign the value of 0. So I'm not going to add negative numbers in this silly code, but just to show some functionality. I'm going to do the same thing for the second parameter. So in this case, I'm going to say PB is going to be a value. So you can see that while I'm writing that function, I see some images or some icons here that are helping me when I coding, and I will just highlight when I just say return PA plus PB. This is the end of my function. I'm going just to run it. It says there is a function. Of course, those are conditional, need to be defined as conditionals, right? So if I say this, say, okay, this code is already silly. I know what it's doing. I can just collapse it and say, this is the function. I don't want to see all the function. I know if I want to expand it, I can go, and I can even do it for the full function. I can do it for long code, for multiple functions. So, oops, sorry. If I have a function that is now called function B, I can start collapsing one by one. So there is another interesting feature that we have on nanohub, right? So let's call my function A now. Let's call this. I'm going to say, from here, I'm going to say function A. I'm going to get the parameters A and B, right? I'm going to add those parameters. The value is 7. Perfect. I'm going to start making wrong things. So I say function is going to be a function, the A, B, right? So of course it doesn't make sense because I'm just adding one parameter. This is going to crash. So I get function that is missing one required positional argument, right? The PB. So before, what basically we have was all the backtrace of the error. Now you are showing the main error. If you want details on what is the error, you can go and say, well, the error was the position, and go specifically on the all long trace of errors. But that is another functionality what we added. Everything is collapsed, so you can exit as you want. So it's another interesting feature. And the last thing that I'm going to say is just copy some code here that this is the markdown. One markdown that is going to be the third part that is writing code, and I'm going to copy a function that is really bad written. So you say, I have found on the internet this nice function that adds 3 numbers, right? So if I run it, of course, it's going to run. I can add the 3 numbers. Right, and I should be able to get the value. Oops, kernel is not running, so my kernel died. I need to restart my kernel. Let me run everything again. Is one don't run? Okay, now I got the value. That's cool, but this is a mess. I don't want that. So what I want to do is make it pretty, so I can use this tool and automatically will just reformat my function, and I will use the standard Python guides to format the function. So you can do that. Yeah, so that is another interesting feature. And lastly, what I want is I add this third part. Let me just add it just like this. I want just to see where are my things. So I create a tutorial. So where is this tutorial I can link, and it jumps to the part for its first part, second part, third part. So I can jump with this table of content in different sections of my notebook. I can configure how it looks. So I say I don't want to add numbers to my cells, or basically ignore the H1, so the main are not going to be counted, only the first part. So you can just start jumping between different parts. Some other cool feature that we have is here. For example, let me see, I have this index right. In this notebook that I showed before, I want to see what is the difference with my repository. So you can go and click this, and it will show what is the difference between my notebook and the notebook that I have in a Git version. So I can just see, well, in this case, I only added this link to this empty tutorial that I've been shown, right? This is what I've shown so far. Is like the new feature that we have, where you can search things from nanohub easy, or in Jupyter easier. You can enable capital lowercase if you want, or some of the things that we have. Something that I didn't show is the change colors. So what it change color means is I have this tutorial, but I don't like this old kind of look of my application, so I can change the cell. So let me just load it. So I have the default theme. I want to change, for example, to a dark type of theme, so it will look a little bit modern, so I can still use all the information. I don't like that theme. I want to change that monokai. So now I have different versions. I say I want to use something that is more nanohub-like, and I will get how the notebook is still functional, but it's still working as it should be. So those are the new, let me just change to default. So the new features that we have on Jupyter, right? So I'm just going to pause to see if there is any question so far.
We did get one comment maybe that came in. I have a query. I am a student of physics background and want to apply AI and ML in nanoparticles material. What is the initial need to proceed?
So probably I will highlight something in the examples that are just examples on how to deal with this particular field that you are interested or you are researching in. So when I go to the atoms and all that part, that there will be powerful examples of how to start with that entry point in your field. So I will try to answer that a little bit later. Okay, so I will go to the first part, is Jupyter 7 atoms and molecule, right? So this is where I'm going to try to show or like explain how you can start working on Jupyter on that particular field. So I have here this example. So if I click on examples, there is going to be a broad spectrum of different type of examples that I have. So how to deal with atoms and molecules, some tools that work with atoms and molecules. I want to work with math or teaching math, Matlab data plotting. That is the example that I'm going to show. You can go to overview, and here are some of the concepts that you can start doing. So it's an open source chemical software that you can be using. So there are examples how to visualize, and if you want basic concepts of chemistry, you can go to these kind of links. So it will highlight how to deal with some of those SMILES structures. So that is one of the examples. Yeah. Right now, I'm going to highlight AtomMan. That is how you can use information about atoms and cells and multi-cells, supercells, how to visualize that kind of molecules. But you have atomistic simulation environment, you have a link to that library, how to deal that with MD analysis, how to do MD trajectories. So those links could be helpful to understand that particular field and the example of what that library allows you to deal with that. So in the Atomman, so if you go to this demo, so you import the libraries, and then, for example, I'm going to create a unit cell. When I define the atoms of my unit cell, I define the coordinates that I want. I'm going to create a super cell that is just a collection of those cells, and I define my dimensions, and I want to see all the atoms and all the properties of that cell. So that will help you just, if I have the directions, I want to just replicate the unit cell in a specific direction, you can start building those kind of molecules or supercells. But you can do elastic contents, you can calculate some of the parameters of those elastic content, distance between atoms. So you can use a lot of utility in those libraries to get information about this particular unit cells. All right. So a lot of examples how to get the atomic mass of that you define. If you want to get the indexes. So there are just a lot of examples how you get information about unit cell. For example, you want to convert Miller's indices to Bravis and Bravis to index. So there are multiple things. So it's more used to explore these kind of examples in how to start getting information of, in this case, molecules. But something that is really interesting is when you create a molecule, the most interesting part is to try to visualize that molecule. And there are some cool libraries that we have installed on nanohub for that. So I'm going to jump to this example links when I have, for example, in GLView. If you have a molecule, a PDB ID, or you have the full description of the molecule, you can run that widget and it will just show all the atoms and the bonding between that. Well, inside of that molecule, so you get information about the protein that is visualized as 3PQR. So you can use that library to do that kind of thing. I will dig a little bit in the NGL view later. But we have other libraries as well. For example, this Py3DMO allow you to do kind of interesting things. So you have an XYZ, for example. This is, again, just a PDB. But if I have an XYZ, I want to visualize that XYZ, you can get, but you can add animation like the vibration. You can modify the amplitude in that vibration. For example, I want to add more vibrations. You can start playing with your molecule. Add different views. So, for example, this is the cartoon version, or you can add some surfaces to your molecule and just visualize all the cartoon and big molecules, so you can zoom in, zoom out, and add trajectories. There are a lot of things that you can add to these kind of libraries. All the links to the description is here when you go to the overview, one that I just closed. In the overview, well, you have, for example, for the NGL view, you have the latest version, and you can see what are the examples that they have, how to render on that library. We have also ipyspec. ipyspec is to visualize XYZ molecules, but it allows you to visualize them in a photorealistic way. So you will get like a cool image of that version. So in this case, it's just a water molecule, but you will get is just a high quality version of that molecule. You can add different versions of how to visualize your molecule, different views or different colors. But you can do the same thing with PDBs, for example, when you can just say, I want to load those PDB, I want to translate from PDB to XYZ, and visualize that molecule in the same engine. It will not be as powerful as the others seem to visualize all the trajectories and all the, but particularly the trajectories that the others allow you. But what is cool is if you have to get a poster for your, I don't know, for a specific symposium, or you want just to add cool images to your presentations, you can just take your molecule or what you are researching, just grab it here, and then you can get photorealistic images of your molecule that could just help you highlighting your research.
All right, Daniel, I have some questions. Do you mind taking a second to answer them?
Yeah, I think that is what I have so far for Atom. So yeah, welcome for questions.
All right, so first question is, for the features you were discussing, such as locking and freezing cells, if the notebook is exported, does that affect compatibility at all with running the notebook locally on Google Colab, etc.?
If you export it, it will be locked if you are running an environment that enables that feature. So it will be compatible, but those features will be lost, for example, in Colab, because Colab don't have that information. So your notebook is going to be compatible because it's following just the notebook format, right? So it's just this JSON structure, but those particular issues that works on nanohub will not work on Colab, or if you go to an abstraction of Jupyter, those will not work there.
Okay. Another question is, I am new to theoretical and experimental computational physics, and I am also interested in nanoparticle synthesis and crystal visualizations. What can you suggest and advise me? Websites, resources, or other database I should know, or anything will help?
For visualization, can you just suggest the libraries that I'm showing and the links that are in those examples? For the specific field, you can search on nanohub for the specific topic, and that will lead to a lot of slides and presentations of different contributors in that field. The other thing is, I didn't highlight here examples that we have, for example, two-dimensional lattice protein simulator. This is just a tool that we have using those kind of features. So if you run it, let me just load, and while that is loading, I'm going to run this PhysiCell as well. And here the main idea, this tool is published, or this notebook is published as a tool, so all the code is hidden. But what I did is to create a sequence here, and I say visualize what this lattice protein will look. So I say if I go, I will get all the confirmation of that particular tool, or that particular sequence. Yeah? So these kind of tools are the ones that you are going to find if you search for a specific keyword on nanohub. So it's more up to you to start exploring those links to see what match the specific field that you want, or the specific topic that you want. For example, this is for COVID. It takes some time to load because it's using the PhysiCell's code. So I will come back to this one in a minute. So yeah, as I said, nanohub search will allow you just to search a specific topic. And what we try is just to tag all the specific content to a specific tag or topic that is interesting. So that is what we try to do, at least our best.
Okay, and then I've got, I think, 2 more questions. Really quick. Could you please explain again how to install modules? For me, the module is still not found after pip install.
So you have to do pip. Let me just highlight this quickly. So here you just create the configuration of this PhysiCell code, and when you run it, it will go to give you some visualization of the atoms and how in this case is the COVID, how it start attacking some of the cells. Yeah, let me just terminate this one and go back to the pip question. So here, basically you have to use pip, and pip, you say pip install and the library that you want. If the library is compatible and doesn't require any extra library that requires some privileges, you can install it. If you have to compile it, for example, that library includes some Fortran code, you can request through a support ticket somebody to install that for the all the community. But you should be able, for example, to install, this one is in Tool Builder, and if you say pip install, you should be able to run it. Some cases, it requires your kernel to be reinstalled because a library requires an external library that was already loaded in your environment. So that is what after installation, you need to restart the kernel to update the packages. So probably you will have to do that as well, if that dependency exists in the library that you want to install. So I'm jumping to Matlab, right? So Matlab, as I said, we have different kernels. So I'm going to, for math, you can explore those as just a library to help you just to illustrate mathematical concepts, integrals, derivatives, things like that. You can even have just a notebook for a class that explains these kind of concepts. But I'm going to jump to Matlab. It's just Matlab. In this case, we are going to use a different kernel. This kernel is Matlab 2021. Let me just close this widget because it's saying that I cannot format pretty Matlab, only can format Python code. So if I want to start a new kernel, when you start or create a new notebook, you have to choose the kernel. So you can choose Matlab. Or if you already create your kernel and you want to change it, you can change the kernel here, change to Matlab. So the first time probably is going to take some time because Matlab the kernel needs to be created. So you need to go to a license, be registered. But as soon as you get the kernel, you can start running Matlab code directly. So if I create just function y and I say what is the absolute and the transpose, find the peaks, and then just I want to print that information. Right, so all that is Matlab, but it's running through Jupyter. So the images takes a little bit of time, but you can render those images created on Matlab on a Jupyter Notebook, right? So it's straightforward. You only have to choose a specific kernel. How I use this kernel particularly is when I'm debugging code. So I'm playing with something in Python that is not working properly. So I can just get some images or some matrices in Matlab, do some quick prototyping in Matlab and run it back to Python. So to do these kind of things, this is another example that I have. So I'm going to run this Python to Matlab first. What I want to create is create a matrix with SciPy. So in SciPy, I create just a matrix using a multivariate normal. I create the variable, and finally what I'm saying is this C object from Python, I want to save it using the SciO library in SciPy as a matrix for Matlab. So if I run it, I will create my mesh.mat, and then I can go to Matlab and say, well, that data is interesting. I want to do some prototyping. I want just to print it. So again, I'm going to use the kernel. Those are some examples of Matlab examples. Those are just more examples of Matlab. I want just to highlight the last one. That is, I want to load this matrix that I created in Python, and then I want to visualize it. So now I'm going to get the data from Python or created with SciPy, and I want to visualize that on Matlab. Again, it will take some time while it's creating the kernel because it has to go through the license. But as soon as I got the license, you will be able to see that. Let me start closing things. I'm not using like this Matlab. I'm not using it. I'm waiting on this one. Yeah, so this time is taking a lot of time to get the kernel. So what I can do is go to my original Matlab notebook that is running, that already have a kernel, and try to run the same command there. So probably there has been a lot of requests for Matlab now, so I will not be able to show this, so I will keep that running and see if I can show it later. So if there are questions, I will answer them. I will just try to go to the next one, that is data analysis. On data analysis, well, if you go to examples again, on examples and data, well, you have pandas. So there is a workshop of pandas if you want to know how to deal with data sets and how to explore data. I'm going to show pretty quickly how to visualize data with pandas. Yeah. So you load the data sets in a data frame, in this case, in random variables with columns A, B, C, and D, and you want to get just highlighted in different colors, and you want to just visualize the value. So this is how you usually get data using pandas. Probably if you are in the field, you are familiar with pandas, right? So I'm not going to show too much of this. If you are interested, you can go to a specific workshop. In that workshop, you will go more details and examples. But something that we have in nanohub, if you have a data set, something that we have on nanohub is this database of results. So if you go nanohub results, so for each tool that we have on nanohub that use rapture of scene tools, basically we have all the data sets or all the data that was created with that tool, and that data is queryable. So for example, you can search for the scene tools or a specific rapture. So if I say I'm going to rapture and I want to search for one of the popular tools that is, for example, pntoy, right? pntoy, I get this function, so I can go to check what is the metadata. The metadata say that for the schema 56, we have that a number of records that are the inputs that we have for that data set, that are the outputs that data set contain. I can go and see, show me all the records. And here for the records, I have the specific identifier and all the values that I have. In most of those tools, I have objects because it's complex data, like dictionaries or arrays or probably a file, so you cannot get it directly. But if you go to the specific link, well, basically you can say, I have values like this POTX is a curve. So I want to see the data, you can click it and you can get the data directly. So I have the x-axis, the y-axis. So that is all the information of that tool. You can get, for example, the files, in this case is a rapture, the XML that were required to run that tool. If you want to query, there is a snap of what you can use in Python to get to that data. You can do the same thing. If I go to results, for example, for a sim tool, in a sim tool, I say, for example, cell relax DFT. So now I different schemas because there are different versions for this tool. I have a identifier, so I can just refer to this data set. And again, if I go to a specific record, I will see all the files associated with that sim tool. So here in files, you can say I have all the inputs that were required, the identifiers, all the node that was used for create that sim tool. So that is a useful data collection, a collection of data sets that you can use if you don't have it. So there is an example of the API, how to use the API to access that data set. So for example, that tool cell relax DFT, I'm going to say I'm interested in the simulations that run that specific material for a specific energy and pressure values. And in this case, I can get the data over here. So I put it on a data frame so I can visualize it. You see there is the lattice vectors, lattice parameters. But I can say, now I want to plot that information on pandas, but using a different backend, in this case, Plotly. If I use Plotly, I will look at that pressure versus energy. You can see all those points that are for that particular thing. So I can even more complicated data, complex data. In this case, from the pntoy, I have curves and I want to see all in this case, is the potential for all those simulations in that specific, so I can get the curves from that specific tool, how they were generated, right? So that is another tool that we have on nanohub. There is another library that we have installed that is called FloatView. I'm going to highlight that library. If you have a data set but you don't know anything about the data set and you want to start exploring into that data set, what you can do is just load your data set in the tool. In this case, I'm going to load the diabetes data set from the scale-learn examples. So here, what I have is multiple factors that can affect the diabetes, and the target is how advanced the disease is. So I can start exploring that information, but I'm going to do it interactively. So I'm going to create this clue manager widget from FloatView, and it will just detect what are the variables that I have in my data set. And I say, well, I'm interested in see what is the information between all those parameters. with the target. Let's say all those. I want to create, in this case, I want to create a correlation coefficient. So I create a new visualization. I can see what are the relation between all those parameters. So I can see if it's really blue or really red, those parameters are more correlated. So S1 is correlated with S2. But if I go to the target, the most important will be the BMI and the blood pressure probably, or the serum 5, right? So I can start exploring. I say, well, that was cool. I want to start digging on those parameters. So I know that for my target, so the BMI was important. I want to start exploring the BMI with the target. So I create a new visualization, but it's going to be a scattered visualization. So I create that visualization. But at the same time, I want to see what is the BP. That was one of the others. So I create the visualization, right? So I can see all those values for high BMI, what is the high density, and for the BP, what is the high target. So I can say, well, that's cool. I want to see, well, what happened with these 3 parameters of these individuals that are over this set, right? So I can see where those are highlighted in my next plot. I say, well, those are really high BMI, and they are really high target of my disease is really advanced. So I want to create a subset. So here I'm going to get, this is my target. So I create a subset. So now those are highlighted with a different color in my data set. I say, now I have that, I'm going to start digging more about that data set. So I'm going to say, now I want to add the S5 and all the other parameters to create parallels visualization. So if I say I want a parallel visualization, I can create visualization. It shows how those individuals are related. So we say, well, I see that S3 is really low, but S1 is not really helping in my thing, so I can just move it, and I'm not interested. And I want to say, additionally to the parallels, I want to create a table when I want to see the data. So I see all the data that is displayed, and I want to see the highlighted ones. So it's over here. I can just say what are the subjects over this data set. So it's going to be highlighted. Or I can say, now I want to add something interactively like Sunburst for that data set. Right, so I can start exploring over that range of data to explore data, right? This is completely interactive. I can say, well, that's cool. I want to export it. I want to add a title to my plot. So I add the title. I want the X's, the Y's. And I say, well, download that as an image. And I can just take an image. So it's a cool library to graphically explore data sets. I can use it in a different way. So if I already know my data sets, instead of using it in a no-modal way, I can use it in a modal way. In a modal way, what you are doing is programmatically, you say, I have my GLUBs, I don't want to display the console. So this is a different data set, is the iris data set. It's another example when I have like the specifics of a flower and what is the category of that flower. I say I'm going to add 2 scatter plots. I'm going to add a table plot of that. The absorbers, the parallels. So I have already preset that, but I'm going to create subset or clusters based on an algorithm. So I'm going to go run this agglomerate clustering from the scale clustering techniques that I have. It's a really basic one, but it's try to guess the groups or my target based on the characteristics of that specific flower. So it created 3 clusters. So I can see the 3 clusters over here. So how they are assigned to a specific target. I can see that the red seems to be incorrect. So I can go to the table here and say, what is the thickness? So target 0, it seems like it was classified perfectly with the green color in this case. The target 1, there was a miss here. Target 2, well, I see that in this case, it doesn't really well good for my target 2. There is another way to use it in a non-model. If you are using a Jupyter lab instead of Jupyter, it will look something like this. If you are using, for example, another data set and you create it, this float view is going to be floating. So you can just reassign it and reposition it wherever you want it. So I say create a contour and a correlation coefficients. I want to add my contour plot over here. I want to add it over the same here. No, I probably will have to add it here. Correlation matrix, I want to add it here. So you can start playing with the location of your visualization. So it's a powerful library to explore. And we have tools, and I think don't have time to highlight those, like the machine learning for material science or the citrine tool for material informatics that explore, particularly material science, how to explore data sets. So that was for the data analysis. I think we are short on time. I don't think I will be able to answer more questions. I will try to highlight the GUI libraries that we have. So if I go to GUI building, we have the submit, that is how to send big jobs to clusters. So if we have a tool like, for example, Quantum Express that want to run in one of the clusters, you can use submit to send those jobs to the cluster. But to create like app of tools, you can use pandas, as I highlighted before. You can use ipywidgets, or you can use nanohub-uidl, that is a library created by Hub0. So I think I'm rushing right now, so I'm going just to highlight the ipywidget. There is a tutorial from the SciPy last year. This is a modified version. You can go over all of widgets, how to add events, the styling, and other libraries that you can use. Like in this case, you can go and say, like, I don't want to use just the basic widgets that are there, but I want to just add a plot, like the ones that you saw with Plotly. I can use NGL view, but I want to modify the visualization of NGL view with parameters on Python, so I can start adding stuff to the visualization. With the ipyspec, I can do the same, changing, for example, the atomistic scale, right? So those are widgets that you can add in your visualization, in your GUI or your app, like BQplot, ipycanvas. There are different widgets that you can use. And if you have three-dimensional data, you can use, for example, ITK widgets to visualize things. This is a little bit heavy, so it takes some time. So, yep, of course. Let me try to run everything from scratch. I'm going to close this one. It's not needed anymore. Just want to highlight this one. That is the widget list. So if you are not familiar with widgets, I want just to highlight this. It will just show all the widgets that are available. So if you have sliders to represent float numbers, to represent integers, buttons, containers like accordion, boxes, tabs. So those are all the widgets that you can use to create these kind of apps. This one didn't load, so yeah, I couldn't show this example as well. You can try to run it later, because right now nanohub is a little bit busy, so it's not running, at least for me. So the last thing that I wanted to show is this nanohub-uidl. This if you want to create your own widgets. So this is just a library to create semantically described web applications, but you can use those applications and build as a widget. So I load those libraries. I create a component here that is just representing a card. So what the widget is just this JSON descriptor with a lot of elements I want to say, but I create the widget directly, and I want to change that right here. So this is what the library allows you. You can just, as I show in other widgets, you can modify those widgets or the value of those widgets as well, right? There is another widgets included with that library. So you can just load those widgets again. I will try to run it. Everything. So you have different ways to represent integers, to represent lists, to represent, this is integers, numbers, to represent booleans, to represent options. So you can have buttons to represent this kind of thing. So you can add those to the library, and they work similarly. So if I say option 2 in the value 13, I want to check the value. So the value now is option 2. I change it again. I want to see what is the value of that. Again, it's option 1. or I can do it the other way. So if I say, for example, this value is 0, 1, 2, so I'm going to add more numbers here. If I die now, this is what I see in this one, so I can start doing things like that. This one is say 6. Oops. So again, I print, and there should be a 6 over there, right? Yeah, so there are widgets that you can use. But the most interesting thing in that library is, since it's just representing any application as semantically, I can start creating something like, I found interesting internet, I found this gingerbread over here. If you go to this LD tutorials to create like this kind of silly pictures, so I can load that in a notebook as I traditionally do, so you can include those directly as HTML, but there is no interactivity over that. What I can say is, what I want you is to copy paste that text that I have over here over this widget, right? So, oops, sorry, this text. PG, I want to copy it over here. And then I want to create one of those widgets over here. So I say, up again. Yeah, no, it's dying right now, so I cannot highlight this one as well. So I'm sorry I couldn't show all the examples that I wanted, but there were technical difficulties. So all that is going to be, all those examples are going to be published on the Jupyter's Guide 7. And questions, I will answer those questions later, as I said in the Q&A. So I think that's it from me, Erin.
All right, thank you so much, Daniel. Can you run a simulation with tools developed in LAMMPS, LAMMPS, or GROMACS, GROMACS?
Yes, there are examples of nanohub. I don't have them on top of my mind, but I can answer those on the QA section of the resource. I don't remember right now.
All right.
Yeah, for the FT, I know we have the FT Explorer or the QA DFT, that is Quantum Espresso. So yes, I will elaborate a little bit later. Yeah, I need to dig a little bit because I don't remember off the top of my head.
Okay. And this one is, have you used the new Matlab AI features?
Yes, but as a test. I haven't just done any like deployment on nanohub, so it has been outside of nanohub. So it should work. There is actually a tutorial on nanohub using some of those features, but yeah, I haven't checked that tutorial. I haven't played it just by myself, so they should be available. I cannot expand on that.
All right. Well, thank you so much for your talk today. We really appreciate it.